Right, guys, if you could comment your names. I was trying to remember where we got to last time. Yeah. I'll have a look. But yeah, anyway, for now, comment your names, guys, and I'll see where we got to. Cool, so it looks like we got to question 12. Which I think was this one. Cool. So we said there's a algebraic way and a non-algebraic way of doing this. Let's. I'll give you guys a couple minutes to have a go at that while I do the register, though. So we got. All right. So Roddy. Fifi, Becca, Sophie, Caleb, Callum. Who else is missing? So Charlie, Joanne, Alex, George, and Leo still missing. Oh, okay. Yeah, so trying this one, guys. I can't remember if we actually went through it or not. I think it was right towards the end. I'm just gonna have a quick check. Oh, yeah, Callum, do you want to be admin instead for today? I'll remove Roddy as admin. We'll switch it around. There you go, Callum. Cool. Yeah. So where do we get to? How long do we have on that question? I think you had a bit of time on that. Yeah, all right, I'll give you 2 minutes to finish this off then. So 2 minutes starting from now, that'll give some other people a chance to log in. So we got George here as well now. Cool. Still no Charlie, Joe, and Alex or Leo though. All right, cool. So 2 more minutes. Sorry, Roddy. 2 more minutes starting now. Cool. I'll just give you guys a chance to try and answer, but no one has. So I'll start going through this. Yeah, as I said, there's two ways of doing it. There's the kind of geometric way, drawing triangles, finding angles, and there's the algebra way, which is quite a bit trickier. So I'll go through the easy way, the triangle way, and then you guys can try the algebraic way afterwards. Cool. All right. So having a look at this one then, we've got two complex numbers, W and Z, and we know the argument of W is pi by 10. So I'm going to draw a Argand diagram for this. So if that's W, the argument of W is pi by 10. And we know the modulus of W is 5, so I could put in a 5 there as well. Right, they also tell us another one, Z, and we know the argument of W plus Z is something as well. Okay, I'm going to draw a bigger diagram. So here's W with a magnitude of 5 and an argument of pi by 10. Z has an argument of 2 pi by 5, which is still less than 2/5, which will still be less than half. So that's still going to be in this quadrant. So I could put Z up here, Z's there, and Z has an argument of 2 pi by 5. And we're told the argument of W plus Z. So if you like W plus Z, this argument here is pi by 5. So using this, we should be able to find the length of Z, if you like. Does that kind of make sense to everybody? So we've got a few angles. We can use the red angle and the blue angle to find this angle here. Yeah, I just think I did this yesterday and I've forgotten what I did now. We can use, what else have we got? Got modulus of that. I could put W in there as well if I wanted. 5 pi over 10. I've completely forgotten what I did yesterday. Pi by 5, no, pi 2 pi by 5 there, so we got that angle. So W plus Z would be going all the way through there. And have you guys got any suggestions? I can't remember what I did. I'll try and find my method for yesterday. Yeah, give me 2 secs. I'm just going to have a rummage around. I'll be right back. If you guys in the meantime give it a go. If you haven't managed to do it, we'll do the algebraic proof afterwards. It's something to do with sine. I use sine rule, but I can't see where the last side was now. Yeah, it'll be around here on the floor somewhere. Back in a sec. Well, I can't find anything, but I think I've drawn too much, basically. Let's draw this diagram again, see if it jumps out. So, W magnitude of 5. Let's draw that in here. We know the argument of W is pi by 10. Right, instead of drawing Z coming from the axis, I'm going to draw Z from W. So if I draw Z up here, we're trying to find the magnitude of Z. So that's what we're trying to find. We know the argument of Z is 2 pi by 5. And then Z plus W is that vector there. We know the argument of that is pi by 5. Okay, that's looking better. Can everyone see why this is now gonna work? So what we can do is, if I work out I'll do it in green now. If I work out this green angle, that's going to be pi by 5 take pi by 10, which is also pi by 5. So also pi by 10. So I draw that in and get rid of this bit. And we know this one has a length of 5. So we can use these angles to try and, I know it looks like a, what's it called, triangle, but it's not. I can use this angle to try and find this enclosed angle, because I know that this one will make a Z angle there. That's how we do it. So if I put in there, that's a Z angle, that is also going to be pi by 10. I can work out this bit. If this is 2/5 of pi, this is going to be 3/5 of pi. And so we've got a triangle where we know one side, we know 2 angles. Now we can work out this angle, therefore we can find the other side lengths. Cool, sorry, I got a bit stumbled there. Right, so if you want to work out this internal angle, that's going to be 3/5 pi plus pi over 10. So that's going to be 6/7 pi, I think, in that one. So I'm going to redraw this just using the triangle now, and just using the bits that we need. So that will make this one up here 7, 8. This will be 2/10 pi or 1/5 pi up there. We know this length is 5, and this is the length that we want to try and find out. Cool. All right, once I've got all that, I can use the sine rule. So we're going to say 5 over sine pi by 5 equals the thing we want, x over sine pi by 10. So x equals 5 sine pi by 10 divided by sine pi by 5. Cool, let's grab a calculator. 5 sine pi by 10 over sine pi by 5 and I get x should be 2.629. Cool. Alright, so George sent me a solution. Let's go have a quick look at his. So George, you're trying it with algebra. I mean, you're close, but you're not quite there. So, yeah, I'll quickly go through how you would do this algebraically. We've got the answer there, so we know what we're trying to get to anyway. I mean, I've said x, but that's really z, isn't it? So the key to this is we've got two complex numbers. The algebra is quite formidable. Again, I did do it, and it was. Oh, maybe I did it on here. Maybe that's why I can find it. Yeah, so what you'd need to do, and I don't know why you'd ever do this because it's a nightmare, but whatever. You could say W equals A plus B I. Z equals X plus IY. And from that we know the argument of W, so tan of theta, let's call it theta 1 for W, equals B over Y, or B over A. We know, and that should equal, so tan of pi by 10 is B over A. We also know the size of W, so we know A squared plus B squared is 5. So that's all the stuff we know for this one. For Z, we don't know much about it, but we know tan of 2 pi by 5 is Y over X. And we also know the argument of W plus Z, so if I add both these together, so we also know that the argument, so we also know tan of pi by 5 is, will that be Y plus B over X plus A. So we basically got these equations. They're obviously not all going to be useful. These two plus these two. And together with those, we ought to be able to algebraically get rid of A, get rid of B, get rid of Y, and end up with X as a decimal. Yeah, I mean, so George, you might have got it right because you are only slightly out. And every time we type in tan of 2/5 pi, we will be slightly rounding. Real quick, let's see if we can get anywhere near it. So I'm going to do this with the calculator, straight in with the calculator, so we know y over x is tan 2 pi over 5, which is going to be 3.0. As long as we go one decimal place, we should be right. So 3.0777. So that's that equation used. You can see down here, tan of pi by 5 is this other bit, so tan of pi by 5, which is something horrible. So y plus over x plus a is 0.7265. And then we've got these two equations. A squared plus b squared is 5. That'll be useful in a minute. And tan pi by 10, so tan pi over 10 is 0.325. So b over a is 0.325. Cool. So if I use the AB equation to eliminate A, we're then going to put that back in to get. Should be able to solve it to find A and B. Put both A and B in there. They've got y over x. And we should be able to solve those simultaneously to find x, find y, square them, add them together, square them. We should get 2.6. Real quick, let's see if we can do it. Actually, real quick, do you guys want to see if you can do it? I'm gonna, give you 3 minutes to try it. No, maybe 4 minutes. Maybe that's a bit tight. So we'll try 4 minutes. I'll do it at the same time, but I would like you guys to give this a go, see if you can actually do this algebraically. It's 4 minutes starting now. Wow, that didn't work. I just tried that and it went to pieces. Roddy, where did I use a plus minus? Was that way back in A and B? Yeah, I mean, I solved a quadratic, so yeah, it could be plus or minus. Should we try with a minus? I'm going to give up on this soon because I don't really care. But, okay, let's try with that instead. So, that should be a minus then, which will give me a plus there, which will give me a minus there, minus there. So that will give me a 3.842 there, which gives me x is even smaller, sounds good, minus 0.2245. Y would be nice and small as well, minus 0.691. No, it didn't work. It should work. I must have made a mistake or rounding errors, but yeah. So that's how you could do it algebraically. I would definitely recommend just doing it geometrically. Cool. All right. Bailing out that one. Let's start what we're doing today. So today we're looking at modulus argument form. If you guys do want to go back and try that, you got the answer now, and that is the correct answer. It should work. I did it the other day and it did, but it's one of those things. You'll never get it bang on, but you might get it close. All right. It's going well today, isn't it? So we can do modulus argument form. So the idea is we have a complex number z with modulus of z. So if we're going to call the modulus r, we're going to call the argument theta. There's a form we can write complex numbers in, which is called modulus argument form, and that form is z equals r cos theta plus I sine theta. The reasons why will be clear very soon, but could you guys for now write that down? This is going to kind of link in with when we do spherical and polar coordinate systems. So you don't have to define the coordinates of something using x and y. You can also use r and theta. So that's kind of where we're getting at with this. It ties in with that topic, but obviously you guys haven't done that topic yet. But yeah, coordinate systems are just ways of saying where things are. We're talking about coordinate systems on Argand diagrams. But the idea is the same. You know, we're instead of, if I draw a quick graph here somewhere, get rid of this. Instead of saying go this many units in the real, this many units in the imaginary to get to this point, there's your complex number. Instead of that, we can say go this length, which we call r, and rotate this argument, which we call theta, and you'd get to the same place. And that's this form of writing your complex number. And you can find the x bit by doing r cos theta like we did in mechanics. So remember r, to find the horizontal, r cos theta would be the real part, and the imaginary part would be r sine theta times by I, because we're on the imaginary axis. So it's just a different way of writing complex numbers using a different coordinate system. So using theta and r instead of x and y. And you'll see we do this in coordinate geometry as well at some point, and we'll be doing 3D coordinates when you can rotate outwards and cut out the side as well. But for one dimension, this is quite a good way of showing our imaginary numbers. Okay, so the proof here is like I just did. I forgot this drawing was on this page. So z equals r cos theta plus I sine theta is the same. These kind of boil down to the same thing. z equals x plus yi. X plus I, y gets you here. So does r rotating theta. We usually give theta the argument in terms of minus pi to pi. Remember, 0, pi by 2, pi, 0, minus pi by 2, minus pi. So we normally do it in those terms. You could do it, honestly, always rotating from here as positive, so you go 90, pi by 2, pi, 3 pi by 2, 2 pi. But we generally tend to put the argument between minus pi and pi. Cool, all right, so the main focus for this week, I suppose, is to convert from one form to the other, which is pretty straightforward. So, you guys are going to try this, because I think we'll jump straight into it. You can try and express this in modulus argument form. I'll write at the top here, r cos theta plus I, I sine theta. Cool, so I'll give you guys 3 minutes to try and do that. Can every single one of you please send me a photo in the Microsoft Teams? So, maybe 4 minutes is the first time you guys done it. 4 minutes, starting from now. See if you can express it in the modulus argument form. Right, so Fifi, Alex, who else we got? Fifi, Alex, and George have had a go. You guys mostly seem to be in agreement. Okay, a couple of differences there. Right, let's give it a go. So I'm going to sketch it first, just so I know what sign I should be giving my angles. So it's -5 in the real direction, minus √5 I should say, in the x direction, and then it's 3i in the imaginary direction. So overall it should look like this. So if I want to find r, that's going to be the magnitude, so I'm going to do r equals √5 squared. That does happen, George, don't worry. Plus 3 squared. Notice I'm skipping the signs there. So r is going to equal 5 plus 9 square rooted. So r is going to be √14. And I would just leave it as an exact value. Okay, the modulus then is going to be tan y over x. So that's going to be tan to the -1 of 3 over √5. So calculator, wherever it is here, tan to the -1, 3 over √5, which gives me a horrible decimal, 0.93. So now 0.93 is going to be the angle measured from x, which is going to be the angle there. I want to measure it from positive x, which is going to be this angle here, so I need to do pi minus 0.93. So if I put all that together, my answer is going to be z equals √14 cos of, and then I need to do pi minus 0.93, which is 2.21, I suppose. Cos of 2.21 plus I sine 2.21. Cool. Right, let's have another quick look through and see who got it right. So, George, I don't think yours is right. Alex, you've said it's down here, so you're wrong. Sorry. Sketch it. Fifi, you've also said it's down here, so make sure you are sketching it first. Roddy, you've said it's up here, so yours is wrong. Joan, you've said it's down the bottom where Fifi said it was. Callum has also put it down the bottom. So yeah, make sure you're sketching these guys. Sketch it before you guess. Oh, who did that? That was Sophie. Spot on. Good job, Sophie. First correct answer. So, does that make sense, guys? So sketch it first, get an idea for where it is, and then you know what the side of the angle needs to be. So it's the same kind of problem we were running into last lecture as well. Right, so I've got another one of these for you guys to try. Give it a go. So 4 minutes on the clock again. That seems to work quite well. Starting from now. Cool, good. Alright, let's do it then. So sketch first. So -1 minus I, so it's going to be down there. So you need to be careful with the angle for this one. We've got Z is -1 minus I, so R is going to be 1 squared plus 1 squared, really. Which is going to be root 2, I think. Yeah, root 2. Oh. Okay, and then finding Z, we're going to have tan to the -1 of 1 over 1, which I think gives us pi by 4. So pi by 4 is the angle here. We need this angle here, so this is going to be 3 pi by 4. And it needs to be negative because we're going that way. So our argument, arg of Z, is -3 pi by 4. So the form should look like this. Z equals root 2 cos of -3 pi by 4 plus I sine of -3 pi by 4. There you go. Right, let's have a look and see who got it right. So Becca, yeah, spot on. Fifi, yeah, brilliant. Roddy, yeah, cool. You guys have all got this now. Sophie, yep. Callum, yep. Joanne, yeah. Try and do it exact, Joanne, if possible. And I wouldn't use the signs in your tan either. Just be careful. Alex, yours is wrong. Oh wait, you got the minus outside the front. What? Do you take it out as a factor? Yeah, I'm not so keen on this one. Check it through, Alex. You've said it's got a negative length, which we don't really do in our in argument modulus form. You're suggesting the modulus is minus root 2, which it can be. So sorry, I'm going to say that was wrong. What did you do, Joan? You push tan instead of right tan. That's easily done. Cool. All right, moving on. So we're going to try some actual questions now. So I've got 4 here for you guys to do. Let's say 10 minutes to do those 4, and I'd like you to send me your workings as well. These are the easy ones. It does get more difficult, but let's get everybody used to pressing tan instead of arctan or the other way around. So I'll give you guys 10 minutes to do these. Please comment if you need any help, and send me photos of your answers as well. Don't forget to sketch. Cool. All right. Yeah, thanks for the photos of work there, guys. That was good. All right, let's get through these ones, and then we'll make it slightly more difficult. So first one, it's going to be 2 plus 2, so it should be a nice, positive, easy angle there. So r is going to be the square root of 2 squared plus 2 squared, which is going to be 2 root 2. And because they're both the same, tan is going to be pi by 4 again, so we're going to get r z, what we're doing, z equals 2 root 2 cos pi by 4 plus I sine pi by 4 for that one. Let's just see what you guys put. Yep, sweet, nice. Okay, good. All right, next one. Let's go down the page. So the next one we'll do E next. Or should we do D next? Yeah, let's do D next. So you got 1 minus root 3 I there. So our angle is going to be a -1, but I don't have to muck around with anything else. So r squared, or r equals, I guess, 1 squared plus 3. So r is going to equal, in this case, 2. And find theta, we're going to do tan to the -1 of root 3, which we should know. I've forgotten what it is, and I've dropped my calculator. Is it 2/3 pi? Might be 2/3 pi. 1/3 pi, that's it. So we get theta is 1/3 pi. Because we're down in that quadrant, we need to have cos minus pi by 3 plus I sine minus pi by 3. Cool. Right, so that's the second one. See how you guys got on with that one. Yeah, that all looks good to me. All right, next one we'll have is part E. So -2 minus 5i. There we go. So finding r, nice and easy again. Square root of 2 squared plus 5 squared. So r is going to be square root of 29. The angle, so we do tan to the -1 of 5 over 2. Which gets me 1.19, which is that angle there. So if I do pi, take answer, we get 1.95. So my angle needs to be minus 1.95. So we get z equals root 29 cos of minus 1.95 plus I sine minus 1.95. There we go. Cool. Did you guys get an exact value for that? No. Why is this coming out different? Alex, how did you get 1 point? Oh, you get 4.33 even. Can't be 4 because that'd be more than pi. So check over what you did on that one again. Sophie, if Teams is crashing, don't worry too much about it. Hopefully it'll be working next lecture. Becca, yours look good. Who's those? Roddy. Roddy, you've done something wrong. I'm not sure what, but something has gone wrong with your workings free. Right, and the last one, 5 minus 5 plus 5i. Minus 5, 5i. There we go. So r is going to be root 50, which is, what's that going to be? 5 root 25 times 2 is 5 root 2, I believe. Ah, cool. Right. So R is 5 root 2, so Z equals 5 root 2. Angle, well, it's 5 and it's 5 again, so it's going to be pi by 4. It's going to be this angle, so this angle is going to be 3 pi by 4. So we get cos 3 pi by 4 plus I sine 3 pi by 4, because arc tan of 1 is 90 degrees, which is pi by 4. All right, so we've got 25 minutes left. I'd like to get a couple more of these done. Yeah, hopefully you can get through both of those. Right, so I'll give you guys 5 minutes to try these two. So it's doing some division with complex numbers and then putting them in the form, modulus argument form. So 5 minutes starting from Cool. Right, let's work through these two. Who have we got then? Who's done an answer? So Fifi. Looks good. Becca. Right. So first one, 3 over 1 plus I root 3. So we need to times this by 1 minus I root 3 over 1 minus I root 3. So we get 3 minus 3I root 3 over 1, and then we're going to times all these bits out, so minus minus is going to be a plus. Root 3 times root 3 is 3. So we get 3 over 4 minus 3 over 4 root 3I. Alright, so we need to find the other way of writing these. So R is going to be 3 over 4 squared plus 3 over 4 root 3 squared, all square rooted. Cool. Which gives me 3 over 2 for R. For tans, we're going to do tan to the minus 1 of 3 over 4 root 3 over 3 over 4. So that's going to basically be tan to the minus 1 of root 3, which I think we did earlier was pi by 3. Tan to the minus 1 root 3. Yeah, pi by 3. Okay, so I just need to sketch this. So we got 3 over 4 in the real direction. Then minus root 3 over 4 root 3 in the imaginary direction. So my angle pi by 4 is going to be there. So the R form will be z equals 3 over 2 cos pi by 4. Pi by 3, wasn't it? Yeah, pi by 3 plus I sine pi by 3. So that's the first one done. So, oh, minus. Yeah, I need a minus in there as well. Cool. So, yeah, Fifi, good. Becca good, yeah. George, yeah, cool. And second one, much of the same, really. Try and hurry up a bit. 1 plus I times 1 plus I. So we're going to get 1 plus 2I minus 1 over 1 plus 1. So we get 2I over 2, which is just I. So draw this one. We're just going straight up there. I there. So the magnitude of this is just going to be 1. So R equals 1. And the angle is going to be pi by 2. So we get Z equals cos pi by 2 plus I sine pi by 2. Cos pi by 2 is obviously 0. I sine pi by 2 is obviously, well, just I. Yeah, that's that one. Cool, I think you've all got that right as well. Yeah, really good. Cool, alright, moving on then. This is probably the last few questions we do today. Just let me check where we're getting up to. We're not doing bad, doing pretty well. So we'll try and get these done. Maybe, what we got, 12 minutes left. I'll give you guys 6 minutes to try these 3, and then we'll spend 6 minutes going through them. That'll be it for today. So 6 minutes starts now. Cool. Right, let's do them. So, first one, expressed back in the other form. So I'm going to do... let's do a quick sketch just so we know we're going to get these in the right place. So 5. The angle is pi by 2. So that must be the angle there, pi by 2. The length is 5. So I know this one is just going to be 5i. So that one was pretty easy. Weird, but pretty easy. Second one, let's draw this. So we've got the angle this time is minus pi by 4. So that's going to be down the middle there. That's going to be pi by 4. And I know the length of this is 2 root 2. So I could just do, to find the real bit, I could do 2 root 2 times cos of pi by 4. So let's do that, 2 root 2 times by cos of pi by 4. So we're going to get 2 plus the imaginary bit, which is going to be 2 root 2 sine pi by 4. Which gives me 2. So 2 plus, 2 minus 2i even. There we go. And the last one there, again, let's draw it. So you've got the angle is 5, 6 pi, so that sounds like it's going to be pointing up this way. So 6 there, that's 5 over 6 pi. So I know the other bit here is 1/6 pi. So there's a couple ways you could do this. I'm going to do 6 times cos of pi by 6. And I get 3 root 3. So I know my real bit is going to be minus 3 root 3. The imaginary bit's positive is pointing up, so we're going to get 6 sine pi by 6. This gives me 3, so plus 3i. So those should be my answers there. Let's just have a quick look and see what you guys got. How many of you actually answered? Roddy and Becca, by the looks of it. So Roddy, Becca even, yes. Yes, yes, cool, awesome. Right, we're going to leave it there then, guys. Next lecture tomorrow, we're going to keep on with this. It does get harder by the end of it. Next week it gets pretty difficult. The week after that it gets pretty more difficult as well, I guess. But yeah, for now, good work today. Make sure your assignment's coming in. We're going to have a skills check on Friday. Yeah, so email me those assignments if you could as a PDF so I can have a flick through them. Otherwise, see you tomorrow. Have a good afternoon. Bye.